Hi there, this is Shrikant Dasari. So in this lesson, we are going to learn about the very basics of linked list, all the basic operations which are provided using the linked list. Okay, so which can be done using a linked list. So in the last lessons, we have done until here. We have created a linked list in the very first lesson, and we have learned how to add a node at the end of the linked list, and also at the beginning, at the end, and after a specific position. Okay. So now in this tutorial, I'm going to cover so the rest of the operations which are so add before position, specific position. Okay. So here. The most common operation, if you open any textbook or if you refer to any online code, you will ever find are these three operations only. So which are add at the beginning, add at the end, and add after a specific position. Okay, so add after a specific position based on the index starting from 0. Okay, so now I have developed the rest of the operations. So add before a specific position based on the index. Okay, and also add after a specific data item. Okay, so this option helps us adding a node after a specific data item. Okay, which is based on a data. And also this operation helps us to add a node before a specific data item. Okay, so these are the operations which we are going to perform. So now, so you might be familiar with so add after a specific question and until here. Okay, so let us run the code here. So what I did is for this tutorial, have written the code previously for all the functionalities, and now like a walkthrough. We will understand how these operations are being performed underneath the hood. Okay, so first let us test the code using all the operations here. Okay, so first I have taken the first option and I am trying to enter a data item here. Okay, so now I am taking the second option, and so if you want to display see the list until now, nothing happens here, only just one item has been entered. So that is these are the contents of the list. Just I have taken the first option and adding at the beginning of the node. So if the node if the linked list does not contain any elements, so if we say that if you take that option as adding a node at the very beginning, is nothing but just the node itself becomes the first node in the linked list. Okay, so next after taking the second option here, I have added another item. So if you want to view the list until now here, so 1, 2 and null, so null indicates that the list is ended. Okay, so null indicates that in order to traverse through the linked list, you need to have some point where you have to stop traversing the linked list. Okay, so ending of the linked list. Okay, so head part and tail part, something that kind of terminology here. Okay, so let me add some more elements here. Let me take the second option and add a total 5 elements in the linked list. So if we display the list here, so here we have all the 5 elements entered in the linked list here. Okay, so now if we try this third option, which we have done already in the previous tutorial, take the third option. It asks us first to enter the data item which you wanted to insert. I am just typing the data item as 99, and and here I wanted to add this data item after a specific position. Let me say that here my specific position is 4 here. Okay, so if I display the list here, so here our index is based on 0. Okay, so the common standard way when we are dealing with data structures is that so we always tend to start the index at 0. Okay, so in order to that, the first position of this element data item 1 is 0, and the position of this item is 1, and the position of this item is 2, 3 and 4. Okay, so in the previous example, the previous run, we have chosen to add a data item after this position. Okay, so based on that position. Okay, so in the same way, if you want to add a specific item, a data item before a specific position, you have to take this option 4 here in the choice. Okay, so again it asks us for a data item. Let us say the data item has 88, and let us say now the position as 4. Okay, So before that specific position, this 88 gets added here. Okay, excuse me. Okay, so now if you display the linked list here, so you get that 88 here. Okay, so previously this is the position, fourth position. Okay, so if you count it now this becomes the fourth position. Okay, so it occupies that position. Now this becomes fifth and this becomes the sixth position. Okay, so 0 1 2 3 4 5 and 6. Okay, and so on and so forth. And also if you want to add the data item, add an element after a specific data item, so here we have this fifth option here. So if you take that and let us say some 77 and let us enter the key item here. Okay, so here it is not asking about any specific position, it's just asking about a key item. So key items are the data items here. Okay, so what are the 1 2 3 88 77 and those kind of things are the key items here. So here I wanted to add that item. I think we have selected after, I think. Oh, I think so. Okay, so if you run that and if you check the display, okay, so add after that specific data item 1, we have added this element 77. Okay, so in the same way, so if you want to add data, so if you want to add data item before any key item, you need to have this, select this option, sixth option here. Okay, so let us say 66 and let us again say the data key item as 2, and if you hit enter, so if you check the display here, okay, so here, so what happens is yes, okay, I think we have let's check this once again. I think small mistake has rolled out here. Let us take the 6 add before data item, sixth one, and let us say the data item as 55 and let us say the key item as 66. Okay, let us take that here. Okay, so here we got, okay, so nothing wrong here. We have taken a data item 55 and we have just added that data item before the key item 66 here. Okay, so let us test it once. Let us test it once again. Let us check the display once here. Okay, so here we have data items here. Okay, let us now select the data item as 77. Okay, so let us add this 50 or 44. Let us take the option here before the data item is sixth option. Let us take 44 and before let us say 77. Okay, so let us check the list here. Okay, it's not getting inserted here. Okay, some sort of mistake is there. Okay, everybody, so I have done a small flaw in the previous example, in the previous run. Okay, so I have just corrected that mistake here. So now if you freshly run the program once again, let us check the code once again, output code. Let us take the choices here, and 4 and 5 and so on and so forth, and let us display the elements. So let us check this sixth condition here, where we are intended to insert a data item before a specific key item here. Okay, so let us take the data item as 11 and let us say the key item as the very first element, which is 1. Let us take the display once again here. So here we have inserted that data item 11 before the key item 1, and also let us continue. So before the data item, let us 6 and let us take the data item as 22 and let us say the key item as 2, and let us take the display once again. So here we have inserted successfully that data item 22 before the key item 2, so on and so forth. You can perform insertions before any element in the linked list here. Okay, so in the linked list, as we know that each element is considered as a node here. Okay, so all these things we have learned in the very basic lesson of the linked list. So the last node, so last node's address part is going to be null here. Okay, so that's the reason I have clearly indicated the null at the ending of the list here. Okay, so while traversing the list, if it encounters the null, it thinks that there ends the linked list here. Okay, so now let us go back to the code here. Okay, so this is the code which I have written. Okay, So here, starting from the display is the very basic thing here. Add at the beginning, add at the end, and add after a specific position. All these things we have learned in the previous lessons here. So now our study will start from here. This function here. Okay. So add before a specific position here. Okay. So just in the previous. We have run that example, and here we are. So this function gives that functionality here. Okay, so in the if you run the code, so this add before position. Okay, so this fourth specific functionality is given by this function here. Okay, so here in the code we have just checking whether the head is null or not. Okay, so this is the very basic check. So if it is the case, then you need to have at least some. The basic idea behind performing this function is that we need to have some elements in the linked list. Okay, so if the head is null, that indicates that the linked list is empty. Okay, so there is no case in point of entering any elements when the linked list is empty. Okay, so that's what if you encounter, if you go back to the execution part and if you take this option for the very first time, so here you have some sort of messages according to the algorithm here written. Okay, so it says that you need to have some elements to work on this option, so hit enter to go back to the main menu. Okay, so if you want to insert an element before any element, so then you are supposed to have some elements, at least one element in the linked list. Okay, so that is the case. So if you have at least one element, so if you take the option 1 and enter an element, let's say some 30 or something like this. So now if you take this fourth option, so you don't get that kind of message here. Okay, so now we have at least one element, one data item in the linked list, which is 30, or one node. So you can happily perform this operation here. Okay, so here is asking us let us say 33, and let us say the position, since we have only one item, let's say 0, and it gets inserted after that specific 0th position or the first element. Okay, okay, so here we have inserted that 33 before that first data item, which is 30. Okay, so that is the case. Let's go back to our code here. Okay, so that is the purpose of this logic here. Okay, so when you're writing programs, your outputs must lead. Okay, so if you skip this kind of condition, then if you don't have elements, then it tries to create an element, then that is not the case. Okay, so that is not the correct way to write algorithm for this kind of functionality. Okay, so in the else part, so if that is not the case, if the linked list consists of some nodes, and if you go to the else part, we have just created a node here, and we have just entered the data item, and we have just made the next part of that data item as null. Okay, so and so on and so forth, and also we have used the scanf function to take the specific position. Okay, so here the position is based on the index, as I've said previously. So if it's 0, then the very first then the node which we have created, which is a new node, must be the very first node. Okay, so the address of that new node must be placed in the head. Okay, so the next part of that new node obviously consists the head's address. Okay, so head is already existing, so if the linked list has only one element, then that element acts itself as a head. Okay, and then if the trying to insert at the 0th position or the very before the very first node, then that new element will become the head. Okay, so that is the case, that is the use of this if condition here. And in the else part, so which is written very carefully, so this is the key point here. Okay, so in this else part, what we are doing is, in order to not to disturb that temp. Okay, so in order to not to disturb that address or the head part, we have created a temporary node here. Okay, okay, so in order to not to disturb the else part, in order not to disturb the head part, so here we have created a temporary pointer here. Okay, so if you go back to the beginning of the code here, along with our new node, we have created this temp node also. So we have just placed that address of the head part in the temp node. Okay, in order to traverse until that point here. Okay, so here what we are doing is, so in the else part, before reaching that position, okay, so position -1. Okay, so we wanted here, our intention is to add the element before a specific position. Okay, so we need to stop the traversing until the point where 1 less than the position. Okay, so here our intention is to add the element before that specific position here. Okay, so that is the reason we have taken here position -1 here. Okay, so in order not to saying that less than equal to, we have just saying that less than position -1, so the loop stops before that element. Okay, so before that element, and here we are if we are saying that temp is equal to null, if here we are checking that so if that position here we have included this condition such that so if we are giving higher position values here. Okay, so if we have only 5 elements, let's say, in our linked list, so our position or our index value must not exceed 4 here. Okay, so if you are giving some 99 or 200 or something like this, so let us test this condition also. So here, if let us add one element, okay, let me say that as 1. So here if I am taking so this option here, add before position, and if I am saying if I say the data item as 22 and if I say the position as 99, so there is no case in point. Okay, so if you say that 99, so there is no such position in our linked list based on the index called 99 here. Okay, so the max here we have inserted only one element. The maximum value you can give for a position data is 0. Okay, so for that reason we have taken that condition here. Let's go back to the code here once again. So for that reason, to trap that loophole, we have added this condition. So if that is not the case, we are just moving that temp part to the temp, or else we are moving the pointer or the node to the next node here. Okay, so temp is equal to temp next. So next part's address is stored in the temp. Okay, so on and so forth. At one point, we will reach to a position where it reaches one before. So exactly one before. The between so before the specific position here. Okay, so at that point what we are doing is we are taking the node's address, the new node's next part, and we are placing that as temp next part here. Okay, and the temp next part becomes temp next part, or else becomes the address of the new node. Okay, so here we are breaking the chain kind of thing, and we are inserting that node somewhere around somewhere in between here. Okay, so if that is the very first node, then it is not the case here. Okay, so to trap if it is the very first case, then here we are trapping that here only. So if you want to do somewhere else in the middle, so this for loop and this core logic helps us here. Okay, so in the same way, so we have this after data part here. Okay, so this is also another key part according to algorithm. So same, the code is also almost similarly same, but here we need a key item also here. Okay, so instead of scanning the position, here we need to scan the key item. Okay, so where so specific item. So let us say for linked list has 5 elements, 5 nodes whose data parts are 1, 2, 3, 4, and 5. So if you want to add a specific data item after that fourth data item, okay, so then you can use this kind of functionality here. Here also we have just taken the data part and key part and a new node and temporary node and all those things, and also we are checking according to the algorithm, as I said previously in the previous function. So first we need to check whether the linked list is empty. Okay, so if the linked list is empty, then there is no case in point of adding a specific data item after key item here. Okay, so the linked list is empty, then it is supposed to have at least one item in the linked list. So that's what the message pops up here. So if that is not the case in the else part, so it's very quite common code as we done in the previous example. So just creating a new node here, entering the data item, scanning the data item, and also we are we just create a node, and then we just scan the we just scan the key item or where we wanted to enter, or where after which data item we wanted to enter that new node or place that new node. We are just scanning that, and also using a with the help of a do while loop, we are traversing. So if until the temporary or the temp node reaches until the key part, we are just moving on the addresses here. Okay, so and while temp not equal to null here. Okay, so and also we need to keep track until where we need to move. Okay, so until until it reaches the end of the linked list, we keep on traversing until we find that key element. And if at all we find that, then we are adjusting our code according to that. So new node next is equal to temp next here. Okay, so new node, the next part of new node will be the temp next. Okay, so whatever the address here, we are trying to insert somewhere around in the middle. Okay, somewhere around in the middle we are trying to insert that element. So add after a specific position, since we are telling that. And temp next is going to be the new node. Okay, so where the next part of that traversal or the node is going to be the new node. Okay, so in that way we are giving some so what we call data. We are inserting the node in between that in between the linked list. Okay, so that is all about so adding after a specific data. Okay, so if you want to check that code here, let us run the program once again. Let us say let us add some data. Let us say 2 and 3 and 4 and 5, and let us display the linked list here. And let us say if you want to add a data item after this fourth key element here. Okay, so let us take this option as fifth option, and let us say the data item is 44, and let us say the key item is 4. And if you take the display, so you get that 44 inserted here. Okay, so until this position you need to traverse. Okay, so the new node. Okay, so the next part, this 44 here, if you observe in the code here, so if we go back to the code once again, so this is the logic which plays the very key role here. Okay, so until it traverses. Okay, so if it founds the key, okay, so if it finds the key there, and then so then what the code says is, this is the 44 is the newly created node actually. Okay, so this must be inserted somewhere around between the 4 and 5. Okay, so the next part of this 45 is going to be the next part of this temp, and the temp next is going to be the address of this newly created node. That's what we have written here. Okay, so in the same way we have add before data. Okay, so add before data, let me stop debugging there. Okay, so that we can run freshly. So add before data, the functionality here is also quite clear. So first, if you want to add some data before any data item, so you need to so check whether the list has some elements, so to perform this operation. That's what we have done in the very first case. And after that, in the else part, so what we are doing is in the same way. So before so we are using this a while loop here. Okay, so while loop, we need to traverse until the key is found here. Okay, so until the key element here is, as in the previous function, the key element is the element where you need to before which you need to insert the data here. Okay, so temp next data. So while until key not equal to temp next data, temp is equal to temp next here. Okay, okay, so here we are traversing until that node in between. So here our intention is to add this 44. Okay, so I've just ran the code here. Okay, I've just inserted some elements, and I have inserted this 44 before this key element 4. Okay, so to do that, if you observe this code, so first, using with the help of this while loop, we have just traversed until that 4 here, and with the help of that, when we have reached there, we have taken this, what we call new node next is equal to temp next. Okay, so now the new node next should be the address of the next node of the temporary. Okay, so that is the case here. So the next part, so the temp next part must be the address of the new node here. Okay, so newly created node. So the logic is quite common. So but we need to be very careful while we are using the loops to traverse until that element, so until where our temp has to stop, and our so how to insert that new node in between those two elements. Okay, so before the temp stops at this third element here. Okay, so in this example the temp stops here, and our key element is 4, and we need to insert that element here in between both of them here. Okay, so this is the logic which is going to help us. Okay, so this is all about the various So functions, let me stop that debugging here. So various functions regarding to the insertions of so all kinds of inserts. Okay, so inserts within the single linked list we have done with. So most probably in the next tutorial we'll learn about how to perform the various delete operations in the within the single linked list. Okay, so until the time, see you, goodbye.